Okay, looking at today's notes, just looking at applications. We've already really talked about the basic exponential growth, exponential decay formula, a times b to the power of x, and then how to find b. 1 plus the rate for growth, 1 minus the rate for decay. Talked about a little bit on that first day where we did all the M&M stuff. We're going to get into it a little bit more in depth today and just practice it a little bit more. So looking at the paragraph up there, it says the quantity that grows or decays by fixed percent at regular intervals possess exponential growth or decay. The equations below. Y would be the new population or the answer to any specific question. A is your initial population. R is the rate of growth or decay. T is the number of time intervals that have gone by, whatever kind of unit of measurement they're using for time in that specific problem. So let's jump down to 1 and 2. Identify if it's growth or decay, and then by what percentage. So number 1, is that growth or is that decay? Growth. How do I know that? Because what is above 1? Okay, because the b value, or 8, is greater than 1. It is a growth by what percentage?
11%.
By 700%. Okay, to find that percentage, it is always the difference between the b value, which is 8, and 1. Okay, the difference between 8 and 1 is 7. And so 7 as a percentage would give you 700%. Number 2, is that growth or is that decay? Decay. By what percentage?
80.
By 80%. Real quick, what is the A value on number 2? 1. This is that situation that I've mentioned a few times before, where if it's just a number to the power of x, there's an understood 1 in the front, which is the A value. Going to 3 and 4. 3 and 4 are pretty basic. We won't really get to the real new stuff till the back. But looking at this, it says enrollment at Wakeland High School is 2,220 students. The annual rate of growth is about 11%. How many students will be enrolled 2 years from now? Okay, so Jessica, what is the initial number of students in this problem? Okay. Gabby, what would my B value be? If it's growth, then I need to do 1 plus 0.11. So my B value is going to be 1.11. And then I would raise that to the power of x. Anytime it asks you for an equation, make sure that you're writing x in there. And then on the next, it would be the next step that you would raise that to the power of 2 to find that the population or the attendance for the high school. So whenever you put that in your calculator, Ashlyn, what'd you get?
2,735.262.
Okay. We'll just go with that right there. Questions on that one? Should be pretty basic. It's a pretty simple example of these. Alright, going to 4, it says Alex bought a new Mustang for $28,585. Mustangs depreciate at a rate of 12% per year. So right there, is that growth or decay? Decay. So am I going to do 1 plus or 1 minus? How much will her car be worth in 3 years, and when will its value be? When will its value fall below 10,000? So what is my initial value?
20,000 or 20,500.
Garrett, Kreitz, what would my B value be? 0.88. On step B, this is whenever I would plug in 3 for x. So Landon, what would the car be worth after 3 years?
$19,479 and around 88 cents.
If it's a dollar amount, a lot of times it's going to be do 2 decimal places on most things. If it's, for example, on the first one, if it's counting number of people, then it would usually be rounded to the next whole number. On C, it says when will it fall below 10,000? We talked about a similar problem on this and how we're solving these right now. How would I do that? Okay, I'm going to put the original equation into y equals. And I'm going to go to the table, and I want to find the first x value that has a y value less than 10,000. So it would be after 9 years. Five says the number of bobcats in Frisco is doubling every 6 months. Currently, there are 200 bobcats in Frisco. How many bobcats will roam Frisco in 4 years? When will their numbers exceed 10,000? So what is the initial number of bobcats in this problem? 200. What is my b value going to be?
2, 4.
Why is it going to be 2? Because it's doubling. Whenever you see doubling, the b value is 2. And then I've got to the power of x. So whenever I come down here, it asks for the population in 4 years. So what am I going to put in for x? No. If it said that it, do what? Why 8? Because it's doubling every 6 months. Okay, there's going to be 8 6-month periods in 4 years. Okay. So you're going to have 200 times 2 to the power of 8. You've got to be careful whenever they change up how they're measuring time on these. So whenever you do that, dog it, what do you get? Garrett?
51,200.
Sounds like it. And what year will the population exceed 10,000? Or how many years will it take for it to exceed? 3. Because x is representing 6-month periods. So if the x is 6, 6-month periods is 3 years.
So they're just doing this to absolutely mess with you completely.
We're going to go through, now listen, we're going to go through this exact same problem again here in a minute, a little bit different way. And if it's if you can convert it easily, and this is an example of one that is pretty easy, you can do it in your head, okay, the conversion. If not, then you might like it the other way. I don't care which way, but you just need to find the way that works best for you. Okay, looking at the back. So on this, we're going to look at special situations. Most specifically, the one we'll look at the most is something called half-life, and we'll get into that. So a specific type of exponential decay where the growth factor is constantly doubling, tripling, or being cut in half. You can use this, and this is kind of the generic form there. But for half-life, then you will need to write this Half-life will always be y equals a times 1/2 to the power of t over k. Those variables, the a and the t are the same. Your a is still your initial value. Your t is time. Your k is your half-life. You can use this same formula for double life, but your b is 2. I'll explain that a little bit further whenever we get to problem number 5. But you're gonna use this formula whenever you have a problem that says half-life in it. Not just half, but it has to say the half-life of this substance is whatever. Okay. Now, you might not know what half-life is. Maybe you talked about it in possibly chemistry. Maybe not. Half-life is the amount of time it takes something, some kind of substance, to decrease by 50%. Okay, so where mistakes happen in this is both the time and the half-life are going to be in units of time. It may say that the half-life of a substance is 1 week. How much is going to be left after 2 months? So you got to know which one. The half-life is the K. The time that it's asking about is T. Okay, so let's go through this and maybe some of you that have lost a little bit, it'll help out. So on 4 it says that half-life, so that right there, I see the word half-life. I'm using the formula that you should have written up there.
Would B just be 1 on this one? Or would B not be 1?
So, always a decay. So what I would do is, as you go through the problem, you can either make a key like that, and you can say, okay, right whenever you see that the half-life is 20, you can put it there. I've had some people that they'll just write the variable above it, as long as you're identifying it. If you start with 100 grams, so there is the initial value, and then it asks how much will remain in 2 minutes. We have to make sure that we have the same unit of time, so we'll convert those minutes to seconds. So how many seconds are in 2 minutes? 120. Okay, you can either put it there or above the 2. You can put T equals 120. And then now I'm just going to fill in that formula, everything that I've got. T is 120. K is 20. Then I'm going to plug that in and see what it equals. So on this one, you should have gotten 1.5625.
How do you switch that?
I think it's nope, it's regular grams. Okay, so let's look at number 5. Number 5 is the exact problem that we did on the front, but we're going to use this formula to do it. So it's a little different. Now, this one says that it's doubling, so I'm still going to use, so now my B value is going to be 2. But everything else is the same. Or I need to go through and identify the A, the K, and the T. So, again, the initial value is 200. My my double life is going to be 6. And then my time, I need to convert years to months. How many months are in 4 years? 48. And now I'm just going to plug everything in like I did on the half-life problem. So it's going to be time over half-life, or double life. I keep saying half-life. So then whenever you put that in, you should get the exact answer we got on the front. Alright, we got two more problems. So please pay attention. And even the last one, we won't go all the way through it. But just because the numbers don't work out nice and neat. So, look at number 6. Says a patient takes 50 milligrams of iodine 131. There's my initial to treat his thyroid disease. Iodine 131 has a half-life. My B is 1/2 of 8 hours. There's my K value. So then it says how much will be left in the patient's body after 1 day. So let's go ahead and write the equation that we would use. So you'd have 50
Wait, you need to find the T.
times 1/2 to the power of X or T over 8. All right, 90% of the time you're going to put X in for time, because that's usually what you're going to ask.
Isn't the time 24 hours?
Yes.
So why would
So now on A, I'm going to take that equation, and it says how much will be left after 1 day. So how many hours are in a day? 24. So I'm going to put 24 over 8. Throw that in the calculator, see what you get. So now on B, it says when does the amount drop below 1 milligram? So you would put this original equation
And why
into y equals, and then you will scroll down until your y value is below 1. But you'll find that it is 46 after 46 hours. It's there. We're going to set it up, and then I'm going to talk about it. We'll be done.
would it matter if you put the 24 or the
It says 80 milligrams of a radioactive substance. So right there's my A value, which is 80. Is stored in a lead lead container. After 3 days, there's my time. 1.25 milligrams of the substance remained. So on this one, we have the A. We know that it is... Sorry, you don't know that it's half-life until you read question A, where it's asking for the half-life. So, because this substance has some kind of half-life, you know that your B value is 1/2, but you don't have the K value. So that's what you're going to put X in for. It gives you time, the 3 days.
Would you put hours, like 72 hours, or just 3 days?
You would put 3 days. So you would have 80 times 1/2 to the power of 3 over X. And we know that after 3 days, it's going to be 1.25. So what you would do in this case, and it doesn't work out nice and neat in the calculator, so just kind of follow me here. You would put this into Y1, and you would go through the table, and you would try to find the Y value, the X value that has that Y value. Now, all these calculators, whenever you go to the table, it counts, the X values count as 1, 2, 3, 4, 5, 6. And none of those are going to give you the correct answer. Alright. The X value that's going to give you that is 0.5. Okay, so if you were to put in 0.5 in here, it would give you 1.25. Now, if that's the answer to this, how many hours is that?
30 minutes.
No.
No.
Oh, 25. 20 what? Double? Oh no.
Wait, hold on. Bring me 30 minutes.
What's the question?
I mean, what?